Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be finishing up the number theory section for Meet 4, talking a little bit about modular arithmetic. So let's get into it. So what we're going to be talking about today is modular arithmetic, because number theory Meet 4 is based all around two big concepts, and modular arithmetic is one of them. So modular arithmetic has to do with what we call modulos, and we call that a mod for short. So a mod is a system of numbers which repeats after reaching a maximum. So it's basically just a number system and based around a certain number, and then after we reach that maximum, it will repeat. So like I said, a mod is based around a certain number. So if we had the mod of the number n, and n is just a variable representing any number, so n could be 7 or 12 or 8. If we had the mod of n represents how many whole numbers there are in that number system. So what that means is, for example, in mod 5, there are 5 whole numbers in that number system. So let's actually look at an example at how a mod works. So for example, if I had mod 8, that would mean that there are 8 numbers in that number system. Now in a mod, you always start counting at the number 0. So if I were counting at the number 0, I go 0, 1, 2, 3, and that's 4 numbers so far, 4, 5, 6, and 7. And then these 8 numbers are the only numbers in mod 8. That's why it's called mod 8, because there are only 8 numbers in that number system. So then how does this number system work? Well, a lot of people like to think about it as a circle diagram. So here I have a circle diagram to demonstrate that concept, which has to do with mod 8. When you reach the last number in that number system and then go one higher, you repeat from the beginning. So let me just draw this out. So imagine you start at 0, and this is representing what mod 8 is. You go to 1, then you keep counting, you go 2, 3, 4, 5, 6, 7, and then once you reach 7, since that's the highest number in the number system, the next number in that mod would go back to 0. So when you're counting a mod 8, you'd go 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, and so on. And you just keep repeating that, which is why if we kept counting in just not in mod 8, we get the number 8. So therefore 8 in mod 8 would be 0, because the number right after 7 in mod 8 is 0. And then if we weren't counting in mod 8, we'd have 9 after that. But in mod 8, 9 is equal to 1, because once you keep counting and going around that circle, when you count 9 numbers, you're going to end up at 1. And we'll talk a little bit more about how to determine what numbers equal what in certain mods later. But essentially, this is how a mod works. Once you reach the maximum number in that mod, you start repeating from the beginning again. And the mod number, which is n in this case, or 8 here, represents how many numbers there are in that number system. All right, so I hinted a little bit at this earlier, but now we're going to talk about converting numbers to mods. So as in, if I had a number that wasn't in a mod, like 79, for example, and I needed to convert it into a mod, such as mod 7, this is how you would do it. So if you have a number x, then x in mod n, and remember, n just represents some mod, so it could be mod 7 or mod 15 or whatever, will always be equal to the remainder of x divided by n. So let me give you an example of this. 100 in mod 8 would be equal to the remainder of 100 over 8, which would be 4 in mod 8. And if we break this down and we relate it to here, we'd see that 100 is our x, because it's the number we're starting with. The mod number, n, is 8. So it's going to be equal to the remainder of x over n, or the remainder of 100 divided by 8, which is 4, because because 8 times 12 is equal to 96, and that's the closest number you can get to 100 before you go to 104. So the remainder of that, 100 minus the closest multiple of 8 is 4. So 100 would be equal to 4 in mod 8. So it's actually surprisingly simple to convert two mods. All right, so we're going to talk a little bit about simplifying equations in this mod based on this rule. So if we have this question, what is 63 times 35 plus 24 over 2 expressed in mod 10? At first, it looks really daunting. And of course, you could just plug and chug it in your calculator, where you just multiply everything out and divide everything out. But because of this rule, where x in mod n is always equal to the remainder of x over n, we can actually immediately simplify this equation. So we can simplify each number individually. So since this is in mod 10 and we have the numbers 63, 35, and 24, which don't exist in mod 10, we can simplify all of those numbers in the equation. So first, 63 is going to be equal to 3 in mod 10, because when you divide 63 by 10, your remainder is 3. So I'm going to write 63 equals 3 mod 10. 35 is equal to 5 mod 10, because when you divide 35 by 10, you end up with 5 as your remainder. So 35 is 5 in mod 10. And then lastly, 24 is going to be equal to 4 in mod 10, because when you divide 24 by 10, you get 4 as your remainder. And again, this concept is surprisingly simple. Mods can get a little bit more complicated in the future, but just simplifying numbers into mods is actually not that difficult. All you have to do is find that remainder. And what we can do from this is immediately simplify the equation. Since 63 is equal to 3 in mod 10, we can just turn this into 3. Since 35 is 5 in mod 10, we can write 5. 24 is 4 in mod 10, so we can write 4. And then 2 stays as 2 in mod 10, because 2 is a number that already existed. And now instead of having to multiply 63 by 35 plus 24 over 2, which would definitely take a lot more calculations, we could probably even just do this question in our head. 4 over 2 is 2, 5 plus 2 is 7, and then multiply by 3 is 21. And I'll just write that out just for the simplification of it. So 3 times 7, and I know that looks like the letter A, 7, and that's equal to 21. And you would have gotten the same answer eventually if you multiplied this all out and then simplified it by dividing by 10 and finding the remainder. But I just find that this method is a little bit more easy if you simplify each number individually first, so you're left with all small numbers to work with when you're actually doing your calculations. Now, it's important to point out some exceptions to this rule, because there are exceptions with numbers that you can't just simplify straight away based on the mod. So the two main exceptions are first, and these are just exceptions to general mod rules. If you have 2x equals 6, for example, or an algebraic equation in a mod, if that was outside of the mod, you could say, oh, 2x equals 6, so x equals 3. And that's a pretty simple equation. We could all say x is 3 if 2 times x is 6. But in a mod, there are multiple answers to this question. I bet you didn't know, but in 2x equals 6 in mod 8, you could also say x equals 7, because when you multiply 7 by 2, that gets you 14. And so 2x equals 14, and when 14 is simplified into mod 8, since the remainder of 14 divided by 8 is 6, then 7 times 2 also equals 6 in mod 8. So x could also be equal to 7. So that's just an important exception to remember, that algebraic equations don't always just have one answer in mods. And then the other one has to do with what we just talked about, where we simplify it, or we simplify everything in the equation immediately. You can't do this for exponents. So for example, in mod 10, if I had 2 to the power of 11, even though 11 simplifies to 1 in mod 10, because it's an exponent, it actually operates with different rules, where we'll get a different answer if we just simplify it to 2 to the power of 1. And if you actually calculated this out, you would get a different answer. But generally speaking, if you have whole numbers that are just part of the equation, where you're doing basic operations with them, such as 63 or 35, and you're multiplying and adding them, you can simplify those numbers immediately with the mod before you actually do your calculations. All right, so now I have a review question about converting numbers to mods and equations in mods. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 5. So let's read the question. And this is actually from an IMLEM meet from 2004. So this is what a question you might see, what it might look like. And you will get word problems like this often, so you need to know how to actually convert them into your equations. So the question says, Coach McMod had his 15 basketball players' jerseys numbered 0 to 14. For passing practice, the players form a circle so that their jersey numbers go clockwise in ascending order. Last practice, Coach McMod gave the ball to the player with jersey number 6 and told the players to pass to the fourth person on their left. After 71 passes, what was the number of the player holding the ball? So let's break down this question a little bit, because word questions can often be difficult to decipher, especially in Meet 4 where you're talking about mods. So let's try to break it down a little bit to quantify exactly what it's talking about. So first it says, Coach McMod have his 15 basketball players' jerseys numbered 0 to 14. So my first thought is, if we're talking about mods, since he has 15 basketball players, then it must be talking about mod 15. And this was confirmed when it says they have jersey numbers 0 through 14. The only numbers in mod 15 are 0 through 14. So we're talking about mod 15 in this question. So it says, for passing practice, the players form a circle so that their jersey numbers go in clockwise in ascending order. All right, so I'm actually going to draw this out because sometimes this can be difficult to imagine. So I'm just going to draw a diagram of that. And actually, that was a bad circle. So I'm going to try again. Okay, that one was bad too, but we're just going to ignore that. Okay, so it starts at 0 and it goes clockwise, which is this direction, in ascending order, which means it goes up. So then we have 1, 2, 3, and I don't actually know where this is going to end. I'm just guessing how far there is in between them. 5, 6, then you have player 7, player 8, player 9, 10, 11, 12, 13, and finally player number 14. So they're in a circle in ascending order clockwise. So it says, last practice, Coach McMod gave the ball to the player with jersey number 6. So player number 6 has the ball and told the players to pass to the fourth person on their left. And often this can be the most tricky part of questions, actually, just deciphering exactly in what direction is the question going. So if they're passing to the fourth person on the left, and you have to imagine which way a person is facing. A person would be facing this way, they'd be holding a ball here, so their left is that way. So the fourth person on the left would be 1, 2, 3, 4. So you jump 4 spaces, or add 4, because 6 plus 4 is 10. And player 6, for example, would pass to player 10. So that means that you're increasing every time they pass the ball. So we told the players to pass to the fourth person on their left. After 71 passes, what was the number of the player holding the ball? Okay, so now we finally have a question. It's saying, okay, we have these numbers in mod 14. We're going to increase by 4 because they're passing to the fourth person on their left, which is an increase 71 times because it's 71 passes. So it's basically saying if we start at 6 and add 4 71 times, then what number is that in mod 15? And so the simplest way to do this is figure out how many spots or how many players you're going to pass around when you're doing this passing practice. So how many spots around the circle you're going to pass when you do 71 passes. And that's going to be equal to 4 times 71 because you're passing 71 times and you're doing you're passing to the fourth player on the left or increasing the player number that has it by 4 every pass. And so we can actually apply a rule about simplifying numbers immediately before you actually do operations. Because we'll find, even for this question, it's definitely going to make it easier to do the calculations. So we can simplify 71 in mod 15 before we multiply it out. And if you found the remainder of 71 divided by 15, because remember, that's how we simplify in mods, that's going to be equal to 11. because 15 times 4 is 60, and then 60 is the closest multiple under 71, and it's 11 away. So if we multiply 4 by 11, that gets us 44. And then all we have to do is add 44 to 6, because we're doing 44 extra spaces. So 44 plus 6 is going to be equal to 50. And then in mod 15, if we simplify 50, we get 50 over 15, and we need the remainder of that. That's going to equal 3 with a remainder of 5. And since our remainder is 5, that means 5 is going to be what 50 is equal to in mod 15, and that's also going to be the number of the player holding the ball. So now we're going to talk about simple algebra-based mod questions, where it's asking you to find the value of a variable. So normally algebra questions that would be simple, for example, if we had 2x equals 6, well, and this was the one we had earlier that I used as an example, you could pretty easily say that x is equal to 3 because 2 times 3 equals 6. But in different mods, they're definitely a little bit more complicated because you can actually have multiple answers to these questions. So the example I gave is that if we had 2x equals 6, but in mod 8, we could say that x is equal to 3 because when we do 3 times 2, that's equal to 6. But we could also say x equals 7 because when we multiply 7 by 2, that gets us 14. And if you simplify 14 in mod 8, that gets you a remainder of 6, which means 2 times 7 is 6 in mod 8. So x would also be equal to 7. And typically questions are only going to ask you to find the answer or the values of the variable between the mod numbers. So for example, if it asks you to find what the values of x were in a question where 2x equals 6 in mod 8, most of the time it'll only ask you to find possible values of x from 0 to 7 because those are the only numbers in mod 8 anyway. All right, so now I'm going to go over exactly how we do these questions. So here I have an example question where it's list all the solutions to the equation 6x equals 12 in modulo 14, where x is limited to the whole numbers from 0 to 13. So the strategy to go about when you're solving these questions is you need to think about what these numbers are going to be equal to or what x multiplies to before it's simplified in the mod. So yes, if we're talking about 6x equals 12 in mod 14, we could say 6x is going to be equal to 12. And then if we solve that, we would get x equals 2, and that would be one of our values of x. But we could also say 6x can also simplify to 26, because 26 simplified in mod 14 is going to equal 12, because 14 plus 12 is 26. And then on top of that, we could say 6x could also simplify to 40. 6x could also simplify to 40 because the next multiple of 14 is 28. And so if we add 12 to that, that gets us to 40. And so if you simplify 40 in mod 14, that also gets you a remainder of 12. So this is the method to go about finding what these values are. You need to figure out what it could be equal to before it gets simplified into that mod. And we could keep going with this. We could say 6x is equal to 54 because 54 simplifies to 12 in mod 14. And then we could do another. We could say 6x is equal to 68 in mod 14. But the way we know how to stop is when we figure out what the highest possible value of x would simplify to. So since the highest value of x is 13, the highest value of x is 13, if we that x could be is 13, if we substitute that in, and then we multiply 13 by 6, so 13 times 6, that gets us a value of 78. So the highest possible value that we would need to solve for is 78, which means if we write the next one out where we have 6x equals, the next one would be 82. And we don't need to solve this one because we know that no matter what value of x we have, it can't multiply to 82. So for this example then, we would have to solve all 5 of these equations to find our values for x because they can all simplify to 12 in mod 14. So if we were to simplify this out, and I'm not going to do all of these because they're not all nice numbers. For this one, we get 6x equals 2. For this one, we would get 4 1/3. And this is why I said they're not all equal to nice numbers. And most of the time in IMLEM questions, they won't ask you to find fractions as your answer. For example, this one would be equal to 9 because 6 times 9 is 54. And I think you get the idea. So the main strategy for this is figuring out what your x, or what this side of the equation, can be equal to before you simplify in this mod. So yes, in this example, it could be equal to 12, but it could also be equal to 26, 40, 54, or 68, because those all simplify to 12 in mod 14. And then you just have to remember that the highest number, or the highest number you have to go up to when you're writing these equations, is the highest possible number that x could be equal to, or that x could evaluate from. So x, the highest possible value of x is 13. So we know that the highest possible resulting value from this side of the equation is 78. So therefore, you don't have to simplify, or you don't have to write any equations where the result is greater than 78 in this case. All right, so now I have a review question about simplifying algebraic expressions and mods. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. All right, so the correct answer to this question was 2. So let's read the question. It says, how many more solutions are there to 4x equals 1 in mod 15, where x is between 0 and 14, than there are to 2x equals 8 in mod 10, where x is between 0 and 9? So the first thing that I notice in this question is it's not actually asking us to find the answers to these equations. So it's not actually asking us to find what the value of x is in 4x equals 1 in mod 15 or 2x equals 8 in mod 10. All it's asking us is to find how many solutions there are and then find the difference between those two, which actually simplifies this question quite a bit, because that's just the strategy that we're just talking about. So let's start with this equation first. We need to find how many possible solutions there are to x in mod 15, where x is between 0 and 14. So let's write out our first equation. So obviously 4x can be equal to 1 in mod 15, and if we were just to simplify that, 4x can be equal to 1, and if we were to simplify that in mod 15, we would get a resulting answer of 1. But we could also have 4x equals 16, because 16 in mod 15 simplifies to 1 as well. And we could have 4x equals 31, because 31 in mod 15 simplifies to 1. And then we could also have 4x equals 46, because 46 in mod 15 simplifies to 1. And so the reason I knew to stop at 4x equals 46 is because I figured out what the highest number that 4x could evaluate to is. So the highest possible value of x, and again, we don't know what they are, but the highest possible value of x is 14. So if we multiplied 4 by 14, that's going to be equal to 56, which means that 56 is the highest number that this side of the equation in mod 15 could simplify to, or evaluate to, which means that we need to solve all these equations, or we need to write all these equations where 4x can equal a number lower than 56. But once we get to a number where 4x is going to be equal to a number higher than 56, such as 4x equals 61, we know that it's not possible for the value of x to be between 0 and 14 to suit this equation. And if you're to actually just simplify out 4x equals 61, you get something like 15.25, which is above 14, which means we know that it doesn't work. And so like I said, we don't actually need to solve these 4 equations. All it's asking us for is how many solutions there are. And since we made 4 possible equations for the value of x, we know that for the mod 15 question, there are 4 possible solutions. So now we're just going to do the same thing for this mod 10 question. So it says 2x equals 8 in mod 10, where x is between 0 and 9. All right, so let's multiply 2 by 9, because this will give us the largest possible value that 2x can evaluate to because 9 is the highest possible value for x. So 2 times 9 is equal to 18. So we know that once we come up with an equation where this side of the equation is equal to anything greater than 18, then we can stop. So let's write out our first equation. We have 2x equals 8, because obviously 2x equals 8 will simplify to 8 in mod 10. All right, but we could also write 2x equals 18, because 18 simplifies to 8 in mod 10, so therefore 2x can also be equal to 18. And then our next one would be 2x equals 28 for the same reasons. But since 28 is greater than 18, and x has to be between 0 and 9, we know that there's no possible value of x that fits this question, which would evaluate to 28. So these are the two equations we have. And I mean, you could solve these pretty easily. This one's 4, this one's 9. But again, we don't need to know what they actually simplify to. All we have to know is that there are two possible values of x for 2x equals 8 in mod 10, which means that the correct answer to this question is 2, because there are 4 possible solutions to the first one, 2 possible solutions to the second one, and 4 minus 2 equals a difference of 2 more solutions. All right, and finally, the last subtopic about mods that we have to talk about are inverses and mods. So in a mod, an inverse is where two numbers m times n equals 1, where m and n are numbers in that mod. So that was kind of like the algebraic explanation, but to give an actual example, 8 and 3 would be inverses in the mod 23, where 8 and 3 are two numbers, because when you multiply them, 8 times 3 is 24, that simplifies to 1 in mod 23. So that's the general rule. If two numbers multiply and then simplify to 1 in whatever mod you have them in, then those two numbers are what we call inverses. All right, so let's go over some rules about inverses. So some general rules about inverses is that every whole number in a mod has exactly one whole number inverse, and that excludes the number 0, because no number times 0 will ever get you to 1. So obviously the number 0 doesn't have an inverse, but every other whole number in a mod will have an inverse. And then the second rule is that the inverse of a number m can also be equal to m. So in this example above, I had 8 and 3 are inverses in mod 23. And obviously 8 and 3 are different numbers. But for example, in any mod, so let's use mod 23 as an example again, 1 will always be the inverse of 1. So 1's inverse will always be 1, because the only number in any mod where 1 multiplies to equal 1 is by itself. If you multiplied 1 by any other number in that mod, such as like 8 or 15 or 22, then it couldn't equal 1 because it would never even pass 23. So in any mod, the inverse of 1 is always going to be 1. So inverses can be equal to themselves, but it still retains the rule that every number in a mod has exactly one whole number inverse. All right, so now we're just going to talk about how to find inverses in any mod. And this is actually kind of similar to the concept we talked about earlier when we're talking about simplifying algebraic expressions. All right, so basically, say we had the question, what is the inverse of 7 in mod 10? All right, so 7 times some number is going to be equal to 1 in mod 10. So we need to think about what numbers, when simplified into mod 10, could be equal to 1. So the number 11 would simplify to 1 in mod 10. So if 7 times a whole number equals 11, then that's its inverse. So 11 equals 1 in mod 10. And just assume that all the other numbers I'm about to list out also equal 1 in mod 10. So in mod 10, 21 will also equal 1. 31 will also simplify to 1. 41 will also simplify to 1. And you see where I'm going with this. So we can use this to figure out what the inverse of 7 is. So let's start with 11. So does any number multiplied, or does any whole number multiplied by 7 equal 11? So if you find that the answer is no, which it is in this case, because 7 times no whole number will get you to 11, then you move on to the next number. So 21 is the next number because it simplifies to 1 in mod 10. So if there's any number that multiplies by 7 to get you to 21, and there is, the answer is 3, then that will be the inverse of 7. So the inverse of 7 will be 3 in mod 10. And if we test this out, we get 7 times 3 equals 1 in mod 10, because 7 times 3 is 21, and 21 simplifies to 1 in mod 10, because the remainder when you divide it by 10 is going to be equal to 1. And this is why it's really important to be able to simplify any number into any mod, or know what a number will simplify to, or reverse, know what numbers are know the reverse, where if you have a number in a mod, know what numbers are going to simplify to that number. So we knew that 11, 21, 31, 41, and so on would simplify to 1 in mod 10. And so you just have to keep going down this path where you eventually will find a number that, when multiplied by the number you're trying to find the inverse of, will equal one of these numbers that will simplify to 1 in the mod you're talking about. All right, and lastly, I have a review question about inverses. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 12. So the question says, in modular arithmetic, a unit is a number that has 1 as a multiple in a particular modular system. Let's say a unit pair is a pair of numbers whose product is 1, and a unit partner is the other number in a unit pair if one of the numbers is known. For example, in mod 7, the unit partner of 2 is 4. What is the unit partner of 8 in mod 19? All right, so this question is really wordy, but it's a really simple question. So I'm just going to break down what this question is saying. So it says, in modular arithmetic, a unit is a number that has 1 as a multiple in a particular modular system. Okay, so basically the system is saying that we're going to call a unit a whole number, because any whole number has 1 as a multiple. And then also including, a natural number, because all natural numbers have 1 as a multiple, because they're just all the numbers without fractions or decimals that are 1 and above. All right, so I'm just going to cross this out, and I'm just going to write unit equals natural number, which I'll write as NN. All right, so let's say a unit pair is a pair of numbers whose product is 1, and a unit partner is the other number in a unit pair if one of the numbers is known. All right, so this sentence is just a really wordy way of saying that numbers have inverses in a mod. And in this example, they're just going to call an inverse a unit pair. So if you have a number, for example, 2, then the unit pair of 2 would be 4, even though we just learned that they're called inverses. Sometimes they'll do this in questions where they'll explain it with different terminology, but you just have to know what that means. So it says, for example, in mod 7, the unit partner of 2 is 4. So we already learned a little bit about this. It's giving an example of an inverse in mod 7, where the inverse of 2 would be 4, because 2 times 4 is 8, and 8 simplifies to 1 in mod 7, because that's the definition of an inverse. All right, so I'll cross that out too, and that's just an example. And it says, what is the unit partner for 8 in mod 19? Okay, so this question was really simple. This is the only very relevant sentence. This is a sentence that's asking the question, and honestly, we really didn't have to know much of this. We didn't really have to know any of this in order to solve this question, except that it says a unit partner means inverse. All right, so it's asking us, what is the inverse for 8 in mod 19? All right, so we know how to go about finding the answer to these questions. We know that 8 times some number is going to equal a number that simplifies to 1 in mod 19. So let's think about what numbers simplify to 1 in mod 19. So obviously there's the number 1, that's going to simplify to 1 in mod 19. Then we have the number 20, because when you divide 20 by 19, you get a remainder of 1. So 20 will also simplify to 1 in mod 19. And you can just assume that when I say equals 1, I mean in mod 19. All right, so another number that will simplify to 1 in mod 19 is going to be 39, because 19 times 2 is 38. So the remainder would be 1. Another number is going to be 58. I meant to write 58. And that's going to simplify to 1 in mod 19. Another number is going to be 77. So 77 simplifies to 1 in mod 19. Another number is 96. That simplifies to 1 in mod 19. And then I'll just do one more. Another number is going to be 115. And at this point, you can probably stop writing out numbers and just test these before you keep writing them out, because it's very likely that when you write out 7 numbers, for example, one of these is going to have a number that multiplies to get your inverse. So first, does any number multiply by 8 to get you to 1? And the answer to that question is no, because you can't really multiply 8 to get a smaller number unless you're multiplying by a fraction or decimal. So we can cross this off. That's not possible. All right, so does any number multiply by 8 get you to 20? So if you multiply 8 by 2.5, that gets you to 20. Or sorry, yeah, if you multiply 8 by 2.5, that gets you to 20. But we are not looking for 2.5. We're looking for whole numbers, so we can cross that one out as well. Does any number multiplied by 8 get you to 39? And the immediate answer is no, because it's not going to be a whole number, because 39 ends in the number 9, which is odd, and 8 times any number is going to be an even number. And so we can actually immediately cross off this one, and this one as well, because 8 times any number will equal an even number, so we know that it can't multiply to an odd. All right, so does any number multiplied by 8 equal 58? And so if you check that one out, you'd also get no. And then eventually you get to, does any number multiplied by 8 get you to 96? And when you find that a number times 8 equals 96, you get 12 as your answer, then that means 12 is the inverse of 8 in mod 19. And if you wanted to check this, like if you wanted to just make sure that this works, then you can multiply 12 by 8, you get 96. And then when you divide 96 by 19 to get what it is in mod 19 and find the remainder, that is going to be equal to 5 with a remainder of 1 in mod 19. So 1 would be what it multiplies to, and 12 would be the inverse. All right, so just to quickly review what we've learned this lesson. So this entire lesson we talked about modular arithmetic, which has to do with what we call mods, which is a system of numbers which repeats after reaching a maximum, where in mod n represents how many whole numbers there are in that number system. And then we looked at mod 8 as an example, where you'd have 8 whole numbers in mod 8, and once you reach the top number, which is 7, you go back to 0 and repeat. So you go 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, and so on. Then we talked about converting to mods, which is actually surprisingly easy. When you have a number that you need to convert to mod n, then the remainder of x divided by n will be what that number is in that mod. So for example, 100 in mod 8 is going to be 4, because the remainder of 100 divided by 8 is 4. And then we talked about simplifying equations in mods, where we could simplify each number individually. So 63 would be 3, 35 would be 5, and 24 would be 4, all in mod 10, before we actually evaluate it out to simplify the equation. And 2 exceptions to these rules generally about mods were, first, that algebraic expressions such as 2x equals 6 in mod 8, those don't always have one answer, but sometimes they can have multiple answers, because a result of 2x could simplify to 6 if it's above 8. And then you also can't use the rule where you simplify numbers before you do the operations on exponents. So you would not be able to simplify 11 to 1 in mod 10 if it were in the exponent. And then we did a review question, and it was a word question that we had to figure out, where the answer is 5. Then we talked about algebra-based mod questions, where I was talking about how there are multiple answers to a question, or to an algebra question where you have to find a variable in different mods. So an example question would be, list all the solutions to the equation 6x equals 12 in mod 14, where x is limited to the whole numbers from 0 to 13. And the way you'd go about finding these answers is figuring out what 6x, or whatever is on that side of the equation, could equal that would simplify to 12 in whatever mod you're talking about, or mod 14. And then we did a review question where we found that there were 2 more solutions to 4x equals 1 in mod 15, then 2x equals 8 in mod 10, with the proper restraint for x. And then finally, we talked about inverses in mods, which is when two numbers in a mod multiply and equal 1 when that result is simplified in a mod. So an example would be 8 and 3 are inverses in mod 23 because 8 times 3 is 24, and 24 simplifies to 1 in mod 23. We talked about some rules about inverses, is that every whole number in a mod besides 0 always has exactly one whole number inverse, and that inverse can be equal to itself. So the inverse of 1 in any mod will always be equal to 1. And then the way we find inverses is similar to the way we simplify algebraic expressions. We figure out what numbers will simplify to 1 in whatever mod you're talking about, and figure out if the number that you're trying to find the inverse of multiplies by another whole number to get to that number that simplifies to 1 in order to find the inverse of that number. And finally, we did a review question about inverses where we found that the inverse of 8 in mod 19 was 12. All right, so that's all I have for today's lesson. I know it was a lengthy one, but there's a lot to cover with mods, and I hope it is helpful. I'll see you next time.